get those kind of energies. Now let's move over to heat energy. We're going to discuss over here. Heat energy is a form of energy which transfers among particles in a substance by means of kinetic energy. It means that by the source of kinetic energy, the particles are transferred in a substance, and those particles, in other words, under kinetic theory, heat is transferred by this particle bouncing into one another. Now, this particle, when bounced into one another, the heat energy, the heat power is produced. And the biggest example of heat energy is our solar system and the sun itself. The sun radiates heat to warm us up on the planet Earth, and the automobile fuel such as gasoline are source of heat energy, as it is the hot engine of a race car or a school bus. Okay, now they've given us examples over here that what are the heat energy that gives us the particles bouncing one another together. They're producing heat energy, and the biggest examples are sun and the fuel and the gasoline used in our automobiles, the cars, and the fire and the coal. These are all examples of heat energy. It can also be used to do work. For example, when a car moves, when the petrol or diesel oil is burned to produce heat, it is also often produced during other energy changes when a coal fire burns, as you can see over here. Now, light energy. Moving towards light energy. What is the light energy? It's also the form of energy which is carried by waves. Okay, anything luminous. Luminous means giving light. Anything luminous gives off light energy, and most of our light comes from the sun. As you know over here, that most of our light, the daylight, comes from the sun. If there is no sun, it means it's night. If there is no sun, it means everything's dark over there, and then we need to use the artificial light produced by the bulbs in our cities, homes, over places they need to get light. There's the artificial light we have produced, and this is the natural light we get from the sun in the daylight. And what does it do? The light we get from our bulbs is artificial, and definition for light energy is it is a radiant energy. The light energy can also be called as radiant energy. It contains light. You can see light energy travels through space where sound can't. The different kind of light waves are part of the electromagnetic spectrum, and light can be absorbed, refracted, and reflected. I hope you've known the concept of light energy. Now moving towards sound energy. Now what does the sound energy do? Like heat and light energy, sound energy also travel in the form of waves. It travels in the form of waves, just like the heat and the light energy. And sound energy can also be sensed with our ears, and it is produced by vibrating objects. Like, yeah, as you can see over here, this is the example of waves, and it in the speaker, the device they've used, the whole process they've used is produced by the vibration produced in the speakers. That gives us the sound we need to hear. And vibrating piano or guitar strings or the vibrating parts of a car engine also are examples of car engine. Sound waves travel through the air to our ears, and sound can also travel through the other gases, as well as through solids, liquids, but sound cannot travel through a vacuum. Now let's move forward to potential energy. Moving towards potential energy, what is that? It is the energy possessed by a body by virtue of its position and configuration. Now it means that where the body is produced, it means the body where it is standing and in which position, structure, form, everything it is standing, it is defining its potential. An example is a rock sitting at the edge of a cliff has potential energy, and if the rock falls, the potential energy will be converted to kinetic energy. It means if the rock is still, it's not moving, it's in its own form, it is producing potential energy. But if the rock moves, falls down, it will produce kinetic energy. Another example of potential energy is when a stretched spring in a pinball machine has elastic potential energy and can move the steel ball when released. Now moving towards what is renewable energy and non-renewable energy, which can be used and which cannot be used again. Now the renewable energy sources can be used continuously without running out. Okay, these are sun, biomass energy, wind energy, the thermal energy, the hydropower, and the energy all together we're getting from the fuel. These are renewable energy we can use again. But what are the non-renewable energy which cannot be used again? These are nuclear, the coal, the fire, and the fuel, and the fossil fuel oil, we cannot use again. They cannot be produced or they cannot be used again. They are non-renewable. Once they have been used, they does not stay as new as they were as when we were using them in the first time. But the sun is same as any other day, the rain is same, the leaves they grow again and again, they grow in the same form. But these energies over here are not in their stays in their original form when they have been used twice or thrice. Now this is a clear picture over here. These were the renewable energy and the non-renewable energy which could be used and not used again. I hope you've known the concept about energy, what is energy, and what are these four forms we discussed today, and some renewable energy and the non-renewable energy.